Hello and welcome to the Redundancy and Fault Tolerance video of the CompTIA Security Plus training course. In this video, we're going to be covering the following topics. We're going to talk about single points of failure, fault tolerance, and redundancy. And with redundancy, we're going to specifically talk about things like redundant servers, redundant network connections, redundant sites, and redundant environmental equipment. Now, before we dive into this particular lesson plan, what I'd like to do is talk about a scenario that's actually happening at Global Mantix Incorporated. Recently, Global Mantix management have noticed a significant increase in system outages, and as a result, core business functionality has been interrupted, and customers have actually been impacted by these outages. This has actually led to a loss in revenue. One key customer is actually beginning to hint at the possibility of moving their business over to a completely different firm, and Global Mantix leadership fears that there may be other customers that are thinking the same way. George Gibbs, who's the director of IT security, did a little investigation into the situation, and he determined that the majority of these recent outages were caused by single points of failure that could have been avoided had mission-critical systems been configured with some level of redundancy and fault tolerance. So he is asking the IT security organization to go through the entire infrastructure and take a look at opportunities to be able to implement redundancy and fault tolerance on all of the core systems. And that'll help provide Global Mantix networks, systems, applications, and data with a reasonable degree of resilience. So in this video, we're going to take a look at the same things that the Global Mantix IT security department is currently going through and reviewing, and we're going to see how it's possible to apply some of these technologies and improve the resilience of the Global Mantix network. So let's define a single point of failure. A single point of failure is an individual device within a network infrastructure or an individual component within a specific device whose failure would actually cause an interruption of service. So obviously, single points of failure are things that we would like to avoid. So what are some single points of failure that we should be concerned about? For example, within computer systems, we have different devices that may fail and may render that computer completely inoperable, like power supplies and RAM and hard drives, network cards, things of that sort. Within a network, any network component or cable that is unique to that particular part of the network connection, that if it were to fail would break the ability for people to traverse that part of the network, would be considered a single point of failure. And then we also have to consider people within our team. Brian here has not taken a vacation for a couple of years, and he just announced that he's off to Florida to go golfing for 4 months because he's got so much backed up vacation time. He happens to know more about certain parts of the network than anybody else, and without him there, we may not be able to fix some of the problems that may pop up. So Brian would be considered a single point of failure. So how do we manage single points of failure within our environment? Well, one of the things that we can do is use fault-tolerant technologies to be able to add some resilience. But what really is fault tolerance? Fault tolerance is the ability for an individual device within our environment to actually remain operational in the event of a component failure. Some of the areas of fault tolerance that we can actually apply to our components within our environment would be things like having redundant CPUs built within certain computer systems, possibly having a device that has dual power supplies or multiple power supplies that will enable the system to continue to function should one of them fail. We also might want to have dual network cards in a computer, or possibly use a group of hard drives instead of a single one, and having them configured using a technology called RAID, which we're going to be discussing later in this video. Another area where we can actually apply fault tolerance within our environment would include things like using UPSs or uninterruptible power supplies to be able to ensure that we have enough time to gracefully bring computer systems down during a real power outage. Also, not every computer system requires the same level of fault tolerance. Some computer systems can actually go down and the business can continue to function, but the business may need those systems to be repaired and brought back up again in a reasonable period of time. So having a well-stocked parts department within your environment would be a great way to be able to make sure that when a system does go down, you have the pieces that you need to be able to put the puzzle back together, if you will. We also mentioned Brian, who's on his way down to Florida now, and we want to make sure that we don't have a situation where he's the only person that knows how to manage issues with specific technology. So having a well-trained team of individuals that are available to respond to issues is another way of really being able to support the concept of fault tolerance. And also documented procedures. During an actual emergency where systems are going down, sometimes it's difficult to really think of a clear way of how we can go about fixing that issue. So having procedures documented and ready to be used is a great way to be able to get those systems repaired and back up and running again in the shortest time possible. So earlier I had mentioned that there was a technology called RAID, which is Redundant Array of Inexpensive Disks, which is a way of allowing multiple physical hard drives to work together as if they were one drive, and to provide fault tolerance so that if one of those drives should fail, the data wouldn't be lost. There are several levels of RAID that we're going to be discussing today. The ones that are grayed out, RAID 2 through 4, will not be discussed because they're really not applicable in the practical world. We're going to talk about the things that you're going to see in the real world, which would be RAID 0, RAID 1, RAID 5, RAID 6, and RAID 10. And notice their names because their names actually give you an idea of exactly how they function, and we're going to explain those as we move through the concepts of RAID. And one really important point that we want to make sure that you understand is that RAID 0, which is disk striping, is not fault tolerant. It is not redundant. All of the other flavors that we're going to talk about today are actually redundant. So RAID 0, which is the non-redundant version of RAID, is disk striping, and you'll notice that there's data that's actually being shared across multiple drives. Now each of these different chunks of data are unique, but these two drives function like one drive. And the value of RAID 0 is that it's a high performance configuration for hard drives. Problem is, if you lose one of these drives, you've lost half of the data that makes up the information that you're trying to use, and therefore everything is lost. And you'll have to replace the bad drive and recover your data from some form of backup. Now, the next form of RAID, which is RAID 1, is called disk mirroring, and you'll notice that there's data that is actually copied to each side of the different disks. So D1 is on both sides, D2, D3, D4, right? So if you were to actually lose one of the hard drives, you would still be okay because you'd be able to function off the second drive. The problem with RAID 1 or disk mirroring is that if you're only using a single disk controller, if that disk controller were to fail, it becomes your single point of failure and you actually lose all of your ability to access data. Now, of course, all you have to do is repair the disk controller, and that particular drive that was still functional, or both drives if they are both functional, will actually be accessible. Now, a way around that is to use a variation of RAID 1, which is called disk duplexing, which actually uses two hard drive controllers, one for each of the different disks. And again, you can see that the data is mirrored, but you've got two hard drive controllers, so that if you were to actually lose one hard drive controller, you would lose access to that drive, but you would still be okay because the second disk controller would allow you to access the remaining disk in the mirror. The next level of RAID that we're going to talk about is RAID level 5, which is disk striping with parity. Now earlier I had mentioned that striping in and of itself is not fault tolerant, but when you add parity information into the mix, you're now able to reconstruct any data that's lost when a drive fails. Now RAID level 5 requires a minimum of 3 drives to function, but you can have more drives than that, and I'm using 4 drives here in my example. By actually using parity information and striping that parity information across multiple drives, you have the ability to be able to regain that data when that one drive fails. So for example, if disk 1 were to fail, we could use the data that exists on disk 0 and disk 2 and the parity that exists on disk 4 to be able to reconstruct A2, and it goes on and on and on. This is a very fault-tolerant technology, but it does have its limits. For example, if a second drive were to fail, you really would be out of luck. You would have to rebuild this entire system by replacing your 2 failed drives and restoring your data from some form of backup. RAID level 6 is very much like RAID level 5, except it uses 2 bits of parity that it distributes across all of the different drives. And the value of RAID 6 over RAID 5 is that if 1 drive fails, you're okay, and if 2 drives fail, you're okay. It's only when a 3rd drive in a RAID 6 array fails that you would be forced to actually restore all 3 drives with new hardware and then recover all of your data from some form of backup. Now, the last version of RAID that we're going to talk about today is RAID 10, which is a mirrored stripe set. It's really a combination or a hybrid of RAID 1 and RAID 0. So we're using mirroring and striping in order to create some form of redundancy. So you'll see here that we have our stripe set here. Between these 2 disks, we have D1, D2, all the way through D7 and D8 and so on. Now, in order to be able to make these particular individual chunks of data resilient or fault tolerant, we've created a mirror on each side of the stripe set. So this is one mirror and this is a second mirror over here. Should I lose a disk in this mirror, and if I were to lose a disk in this mirror, we would still be able to function without any interruption of service. Now, another fault-tolerant technology that you're going to see installed in data centers is something that's known as HVAC, or HVAC, which stands for Heating, Ventilation, and Air Conditioning Systems. Now, your HVAC systems are considered to be fault-tolerant systems because they provide a compensation factor for the natural buildup of heat in our data center that happens just because we're installing a lot of electronic equipment that happens to generate heat. And it's also considered a fault-tolerant technology because, as we all know, heat and electronic equipment don't mix very well. Heat becomes a detriment to the performance and the life expectancy of your electronics. So we cannot just let that heat build up and then do nothing about it. We need to compensate for that buildup of heat, and that's where our HVAC systems actually come into play. Now, when we're designing our data centers, one of the things that we have to take into consideration is how much electronic equipment is going to be installed, how much heat do we believe is going to be generated by that equipment, and therefore how much HVAC do we need to keep the environment cool. We have to ensure that our data centers maintain a proper operating temperature at all times. Now, another aspect of the design of HVAC would be how can we make sure that that cool air that's being generated by these systems get distributed over our electronic equipment in an even enough way to make sure that everything is cooled down. I can't tell you how many times I've walked into a data center where at first glance I walk in and I think, you know what, this is cool, it's chilly, everything seems to be running just fine, and I walk down a few rows and all of a sudden, bam, it's super hot in that area. And I realize that, you know what, they have enough cooling, they have the capacity to cool everything, but for some reason they're not getting the cool air to this area of the data center. So I check on that equipment that's in the racks in that area, and absolutely they're running at much too high of a temperature for their own good. So we have to make sure that we get that cool air distributed. It's not enough just to put the capacity in, but if it can't be delivered where it's needed, then it's doing you absolutely no good. Now, another nice benefit to having HVAC in our environment is we have the ability to control the humidity levels in our data center. And once again, with electronic equipment, too little or too much is not good. So we want to make sure that we keep our humidity at a proper level. Now, if it gets too low, we're going to end up having things like electrostatic discharge happening, where even just walking by and rubbing up against a rack door, for example, could transfer static from us into our equipment and potentially damage components within the equipment. And we might not have even felt the discharge of electricity between us and the gear. Sometimes we'll feel a spark, sometimes we won't. But nevertheless, the damage was done. So you want to make sure that you're keeping humidity at a reasonable level so that ESD is not an issue, and that you're just not getting a lot of moisture buildup in the environment as well, because that would be bad as also. So how do we figure out what that range is? What's considered to be a reasonable range for the buildup of humidity in your environment? Well, there are individuals that say between 40 and 55% humidity is perfect for a data center. And I agree that that's in a range that I'm comfortable with as well. But there are other camps that believe that the range should be between 20% and 80%. Now, in my opinion, the 40 to 55 feels better, but that's a pretty narrow range that you're playing with. And I tend to like to recommend to my customers that they're using between 40 and say 70%. I believe that 40 at the low end is a good number, because any lower than that and you do start getting into ESD issues. And then again, at the high end, I think 70% is still reasonable, and I wouldn't want to see it getting much above that. Now, the last fault-tolerant technology that we're going to be talking about in this video is something known as fire suppression technology. We have to be prepared to deal with any fire outbreaks in our data center. And obviously, whichever fire suppression technology we choose, human safety is going to be the primary objective, making sure that the people that are working within our data center are protected. Then, job 2 is to make sure that the equipment and the data that's being stored on that equipment is also protected as well. The best case scenario would be that a fire that breaks out in our data center is suppressed quickly, and that all of the other equipment other than the one that was engaged in the fire will all be able to be used normally within just a short period of time, and that maybe only that one damaged piece of equipment or the few pieces in that immediate area may actually have to be replaced or rebuilt. So with that in mind, there are different fire suppression technologies that could be used to fight a fire in our data center. Water happens to be one of them, but it wouldn't be my first choice because water and electronics, anything water and electricity generally is not a good mix. But it is capable of putting out the fires that are in our data center. But at what cost? At the cost of the whole data center potentially, because once that water starts flooding out of the sprinkler systems and into our environment, all of the equipment is potentially going to be ruined by the fact that it has all of that moisture built up in it. Shorting is going to take place, and who knows what damage is going to be done just by nature of using water. So if you don't have to use water, that would be best. That's why from a data center perspective, we choose to use some gaseous form of fire suppression technology as our primary technology. Most local jurisdictions require water-based fire extinguishing systems to be put into their environment, even though gaseous-based systems are often the ones that we would prefer to use for computer room technology. Now, that just means that we have to follow code. The local municipalities require that we put water in there, but they don't require that we use them as a first step. So what we do is we install those along with gaseous-based systems, and then we make the gaseous-based systems our primary fire suppression technology. And only if those systems do not do their job and then the fire continues to burn will the water-based systems actually take over and put the fire out. And that's reasonable because by then the situation is really bad and you have no choice but to use those water-based systems. But try to not use those as your first line of defense. Make them your backups only. Now, with regards to the different types of technologies that are available, I've got a short list here of some of the different technologies. So you've got water, you've got halon 1301, you've got carbon dioxide, you've got Energen, and you've got Fe227. And these are the actual chemical agents that make up these different types of technologies. And these are the techniques that they use for putting out fires. So obviously with water, H2O, it's flooding. They just basically flood the data center. Obviously not floor to ceiling, but enough to put the fire out. Halon 1301 has such a bad effect on the ozone and the environment in general that it's been banned by almost every country in North America, actually throughout the world. Nobody is actually using halon as fire suppression anymore just because of the environmental factors. Now carbon dioxide, which is CO2, displaces the oxygen in the room. So if there's no oxygen, fire can't burn. But if there's no oxygen, people can't breathe. So you have to make sure that if you're using carbon dioxide technology, that people know that the minute that the alarm goes off in the data center, which tells you within a certain period of time that these systems are going to discharge their chemicals or their agents, that you've got to get out of the data center. You must leave now because in a few seconds from now, there won't be any oxygen for you to breathe, and that could be bad. Now with Energens, basically they reduce oxygen levels as well. and they use less carbon dioxide and a combination of other agents, so not quite as detrimental, but nevertheless you would want to evacuate that data center the minute these systems are going to go off so that you can be in a safe area and then let these technologies do their job. Now, Fe227 actually cools the fire at the molecular level so that it just can't burn. And again, these are different technologies. They do their job differently, and you would want to just investigate them and decide which ones of those systems you're going to want to put in your data center. Now that we've talked about fault tolerance, let's take a look at redundancy. And before we actually get into it, let's actually define what redundancy is. Redundancy is using duplicate systems, networking devices, or data paths to enable functionality to continue when a failure occurs somewhere in the environment. So to begin with, let's take a look at redundancy from a server perspective. And there are a couple of common ways that we actually create server redundancy within our environment. The first one we're going to talk about is using a load balance scenario. So we basically have 3 servers here in our environment, and these 3 servers all have the same application installed on them, and they're all performing as equal members of this team of servers providing this application to our environment. And when our client needs to access this application, their request will go through a device called a load balancer, and it will decide which one of the 3 servers in this example to send the request through. So as long as all of the servers are up and they're all equally busy, the load balancer is going to send requests to each of the different servers. Now, should one of those servers actually have a problem and go down, the load balancer will know this, and it will then route traffic off to just the remaining servers that are part of the team. The next server redundancy configuration that we're going to talk about is called clustering. In this example, I have 2 servers that are configured in a active-passive configuration. We have a primary server that is currently active, and it's receiving requests from clients, and it's accessing the data, the shared data storage that's on the back end, and it's doing all of the work. Now, the secondary server in this configuration is currently passive. No traffic is going through it. But there's a heartbeat connection going between the primary and the secondary server, and it's really the secondary server that's querying the primary server on a pretty frequent basis, wondering, are you alive? Are you alive? Are you alive? Are you there? And as long as the primary server responds with a yes, I'm alive, they'll stay in this configuration. But should that primary server actually go down, what will happen is the secondary will take on the role as the primary, and it will become active, and all traffic will be passed through it. The secondary server will go inactive, and you'll now have an opportunity to be able to shut it down and do any repair that you may need to on it, and eventually you can reintroduce that server back into the cluster. Another critical area where redundancy is required is in your storage area network. Anytime you have large amounts of critical data that a company needs to be able to protect, you're going to need to have some form of redundancy in place to provide that level of protection. So in this particular example, we've got a storage array that's actually mirrored across 3 completely different sets of disks. And these are actually disk arrays, so there's multiple disks in each one of these is what this represents. We also have redundancy at the fiber switch level because this is how the rest of the environment gains access to the storage area network. So we want to make sure that if a fiber switch were to go down, we would still be able to access that critical data. And then even from an access perspective, we have our gigabit switches, for example, our Ethernet switches that our servers are connected to, and we would want to have multiple connections to the gigabit switches, and we would want these gigabit switches to be trunked up to the fiber switch using multiple connections as well. That way, should any single connection go down, we still have multiple paths to be able to get to that data. Now we're going to discuss network redundancy. Now, considering the fact that the network infrastructure is the roadway that all communication travels on, it's really important that we eliminate as many single points of failure on our network as are possible. We want to have a highly redundant environment in order to be able to ensure that we're going to have availability of traffic flow anywhere within the network. In this particular example, you're going to see that we have multiple paths coming in from the internet in through these routers. We're going to have these routers routing to multiple access switches, and each of these access switches are being connected to by multiple servers that have multiple paths, and this side of the network is actually connecting to this side of the network through redundant core switches. This particular configuration will provide this company that uses this configuration with high availability. This is truly a redundant and resilient network configuration. Now let's take a look at redundant sites, and specifically we're going to start off our discussion by talking about hot sites. We have to take into consideration when we're trying to plan for redundancy and resilience the possibility that our entire environment, the entire data center that we do business out of, may actually have a catastrophic failure. There could be fires, there could be floods, there could be other natural disasters that might actually impact our ability to continue to do business out of that production site. Now, a hot site is a site that is away from our main data center in a completely different building, usually in a different city somewhere else in the country, that has duplicate equipment that we need to be able to continue to do business should there be a catastrophic interruption back here at the production site. Now, during normal business operation, what you'll see is we have similar servers and storage, and the data that exists in our production storage environment is real-time replicated over to the hot site so that it's always up to date and current. Should there be a catastrophic failure back here at the production site, all you would do would be reroute customers back over to the hot site, and you could continue to resume business. Now, this is an expensive proposition, but for highly available environments that are generating tons of revenue, downtime is too expensive, and it's important that you get your systems back up and running immediately. So a hot site may be your only solution to the business requirements. So it is certainly something that needs to be taken into consideration. Now, one last little point. In a hot site, all of the equipment that sits there is dedicated to your company. The floor space, the equipment, the electrical, the air conditioning, the costs of all of that operation, all of the data, the pipes that you need to transmit your data across from one site to the other, all of that is one expense that is all yours. You can't share that expense with any other customer that manages this hot site. So it's an expensive proposition to put that type of infrastructure in place. Now, an alternative to a hot site would be a warm site. So in a warm site, maybe part of your infrastructure is in place. And of course, getting your data from your production site over to a warm site sometimes is the most problematic. And it's the data that is really critical in order for you to be able to do business. So many times companies will still replicate the data between their production site and a warm site. But should there be a disaster that occurs back at the production site, the company would then send people out to the warm site, the disaster recovery facility, and they would actually go into a recovery mode where they would take shared servers and they would build them out with operating systems and put the applications on them and put the infrastructure in place in order to get back in business. It doesn't cost as much to do this, but it certainly takes longer to get your business back up and running again. Now, in some cases, there's also another alternative which is much less expensive, which would be a cold site, which basically gives you access to a facility that you can send your people to. And yes, there is equipment there that your people can use, but it all needs to be set up from scratch, and you have to restore all of your data from tape or other backup media in order to be able to get your business up and running. And so again, while the costs may be less than a warm site or a hot site, the time to recovery is also considerably longer. Some companies will use a combination of hot sites, warm sites, and cold sites in order to be able to make sure that they're not spending too much money to recover stuff that's not critical day 1, day 2, day 3 of a disaster. Maybe things that can be recovered in a week would go to a cold site, but the things you need to have running in 20 minutes or an hour from the disaster maybe would go to a hot site. So these are ways of being able to plan for redundancy at the site level. Our final point on redundancy is environmental components. So for example, what if there was an incident that took place back at the power company that actually caused our data center to go dark? We were actually losing all power from the power company. Now, if it was just a few short seconds, our UPSs would take care of that. If it was a few minutes, maybe they would take care of that as well. But what about an extended outage that may last hours or days? In order to be able to prepare for those types of outages, we would need to plan for the installation of power generators within our data center environment. Also, what about temperature? What about humidity? Air conditioning systems are critical to a data center in order to ensure that our computers are operating at the proper temperature levels and with the proper level of humidity. Now, most air conditioning systems over time need to be maintained, and they need to sometimes be repaired because they just break down. So having a redundant set of air conditioning units within our data center is also important to having proper control over our environmental components. Okay, so what did we cover in our redundancy and fault tolerance video? Well, first of all, we talked about single points of failure. And a single point of failure we talked about as being any component within a system that if it were to fail, it would cause that system to malfunction and to not actually provide service to the business. But we also extended that out to the data center as well. So any single system or any component within the environment, like any single switch or any single cable or any single data path from point A to point B on the network, that if it were to be interrupted would also eliminate service to the business, would be considered a single point of failure. And these are things that we want to try to eliminate as much as possible. How do we eliminate these things? Well, we talked about fault tolerance, for example. Within a single system, we can add duplicate components in order to be able to make sure that should they fail, we can continue to use that system to do the job that it was intended to do. So we talked about things like maybe multiple network cards, or we even talked about multiple hard drives using RAID, which is a redundant array of inexpensive disks. And we talked about the various RAID levels and what they do with regards to providing protection from outages. We also talked about redundancy, and specifically redundancy is adding multiple systems to your environment in order to be able to make sure that should one of those systems go down, that we could continue to do business. We also extended that out to the network infrastructure and not only have multiple network components, but multiple paths to those components. So lots of extra wires to connect us up so that we have multiple ways to get from point A to point B. So we talked about redundant servers, redundant network connections, redundant sites, which again, should our entire data center have a catastrophic outage, where are we going to go in order to be able to continue to do business? And then we talked about redundant environmental equipment like power generators to be able to replace the power company should they have an extended outage, or the air conditioning systems within our environment and how important they are, and if they go down, what are we going to do in order to maintain proper temperature and humidity in the data center? Now, another point that we talked about earlier in this video is regarding global mantics and the fact that lately they've been experiencing an increase in system outages. And as a result of these outages, we know that availability of their systems has suffered, and possibly even data integrity, which we know that integrity and availability are two of the CIA tenets, which is confidentiality, integrity, and availability. Now, whether these single points of failure were caused by a lack of fault tolerance, a lack of redundancy, or a combination of both, it's really important that Global Mantics identifies where these single points of failure exist and have a plan in place to be able to eliminate them wherever possible. As an IT security professional, now that you've reviewed this video and you've learned these topics, you should be prepared to go into Global Mantics and do a gap analysis to find out where these single points of failure are. You should also be able to make a recommendation to Global Mantics as to what levels of fault tolerance they should be putting in place and what redundant systems they should be building into their environment in order to make their network more stable. Now that you've completed the redundancy and fault tolerance video, the vocabulary that you should be familiar with includes things like single points of failure, individual devices or components within that device that if they were to fail would actually cause some form of interruption of service. We need to be able to identify single points of failure on the network and then make plans to actually remove them by putting redundant components in place and by putting fault-tolerant technologies in place. Speaking of fault tolerance, that's another vocabulary word that you should be familiar with. It's the ability for an individual device to remain operational even though a component within that device were to fail. So putting multiple power supplies in servers, or putting multiple CPUs, or multiple hard drives configured in a RAID configuration, these are all ways of being fault tolerant. Redundancy. Once you've actually got fault-tolerant systems in place, if you only have a single system, it still, as a whole, is a single point of failure. So for mission-critical systems, you want to have duplicates of them, whether they're going to be configured in a load-balanced configuration or possibly in a clustered configuration. These are all ways of being able to ensure that should one of those devices fail, the environment can still function. And that extends out to the network as well. Multiple switches, multiple router routes, multiple cables to those devices so that any one point of failure is eliminated. RAID is redundant array of inexpensive disks. It's a configuration of multiple drives so that they look like one hard drive to a particular system, and if any one or potentially even up to multiple drives fail, depending upon which RAID level you use, the system won't die. It'll actually continue to function. Hot sites. If our data center were to catastrophically be impacted, one of the things that we might do is we might move out to a hot site, which is a disaster recovery location that contains all of the configured and functional components that we need to sustain production. So it really takes all of the core systems and duplicates them full time at that disaster recovery site, including our storage and all of our data, and our production data is real-time replicated over to that hot site. It's an expensive proposition because we own all of the equipment, we own all of the data connections. It's not a shared resource, so the expense of that is completely on that one company that uses a hot site. However, it is fast recovery. If you need to be back up and running within minutes, that's the way to go. A warm site, however, is a site that maybe you don't need to be back up and running within minutes or an hour. Maybe you can take a day or two to actually get your environment back up and running again. Well, a warm site is a disaster recovery location that contains some of your configuration and functional equipment. Not everything, though. Just certain things that are super critical, and you're still going to have to go there and set up the remainder of the equipment and get it configured in order for your full functionality to be restored. A cold site, on the other hand, is a disaster recovery location that contains little to nothing in the way of setup and configured equipment. Maybe the equipment is there, maybe it's being used by another company at a given point in time, but as long as it's not, and if you do declare a disaster, you can then show up at that site, you get to use that equipment, and you can restore your data onto their systems, and you're going to need to bring all your backup media there that you have and get all that data restored and build all your servers with operating systems and get them all configured on a network, and then you can restore business. So it may be less expensive to use a cold site, but it's a much longer recovery period in order to get your business back up and running. Disk mirroring is a RAID configuration that actually creates a duplicate copy of data on multiple drives in your system. So at any given moment in time, your main hard drive that holds your data has a full copy on a second drive. That way, should your main drive fail, the system can continue to function by using that secondary drive or the other side of the mirror. So even when the mirror breaks, your system will continue to function. This is a very fault-tolerant technology. This is a good thing. Now, disk striping, on the other hand, is very different than disk mirroring. Disk striping takes the data that's coming into your computer that's being saved to the hard drive, and it writes that data across multiple drives. In other words, it takes part of the data and spreads it across multiple drives. So no one drive holds all of the information. It's a combination of all the drives that are in the disk stripe set that actually hold the collective data. So any one drive that would fail, you would lose all of your data. Of course, disk striping does enhance performance of your hard drive subsystem, but it is not a fault-tolerant technology. Parity is a way of taking disk striping and making it fault-tolerant to some degree. What happens is that along with striping information across the multiple drives, parity information is calculated and also written across multiple drives. And that parity information is used to be able to recalculate the data that was lost should a drive fail, and then be able to keep the system up and running. Now, depending upon the RAID level you're talking about, whether it's RAID 5, which is stripe set with parity, or RAID 6, which is stripe set with dual parity, you could lose one drive with RAID 5 or two drives with RAID 6. So again, anytime you're doing a disk striping with parity, you do have fault tolerance built into the environment. Well, I want to thank you very much for watching the redundancy and fault tolerance video. I hope you enjoyed yourself. I hope you learned a lot, and I look forward to seeing you in the next video.